Delete operation is removing an element from a given index. Obviously, when we want to delete something, then we should mention which element we want to delete. So we can mention index. So as an example, I have taken delete element 3 at index 3. So this element I want to delete. So for deleting this element, so first of all, you take out the element from there. So taking out an element, so I can take out x assign a of this index, whatever the index is given. Now we have an element that we want to delete that is present here in x. So let us say 12 is present in x. So we have taken out the copy of an element. Now when we say this element is not there in the array, then this space will be blank. So remember this, we don't leave blank spaces in between the elements in an array. So if you are saying that that element is not there, then we don't know what all the other elements are there or not there. So then it becomes difficult for us to find out whether the element is there or not there. When we delete the elements from an array, then that space we don't leave it vacant. If we are leaving it vacant and assuming that the element is not there, then for every location we have to check whether the element is there or not there. So it increases our work. So instead of keeping that space blank, we will shift all the elements. So whenever we delete an element from an array, we have to shift the element to occupy that blank space. So what I have to do is shift the elements from here. So being here, let us again take I, which will shift the element, then move I and shift the element, then move I and shift the element. So it's going in forward direction now, and move I, then shift the elements. I should not move further because this is the last index where I have an element that was length -1. So I should stop before length -1. So I should shift all the elements one by one, starting from a given index and reach till length -1 location or before length -1. So the shifting of these elements can be done using for loop. So let us start I from the given index, and being I here, it can copy the element from the next index. So let us write a for loop for I starts from given index. This is the index is 3. So from index, and where I should stop, it should stop at 6. Being at 6, it can copy the element from index 7. So I should be less than length. See, actually length is 8. Less than length means 7. No, it should stop at 6. So length -1. And I is moving forward every time. So I plus plus. Now what I has to do? Being here, it should copy the element from next index. So at A of I, it should copy the element from A of I plus 1. That's a loop. Now with this loop, I here at index 3, it will copy 15, then I plus plus, then being here, it will copy 6, that is +1 is copied here, then I plus plus, now I is here, so it will copy the element from next index, so it is at 6, so it is at index 5, so it will copy 9, then I plus plus, it should copy 10. Then after that, I should stop. Yes, I is less than length -1. Length -1 is 8 minus 1, that is 7. So I is 6 now. 6 is less than 7. So if it becomes 7, it will stop. So this has moved all the elements or shifted all the elements. So this element is removed. Now as the number of elements has reduced, so this should become 7. So here I should decrement the value of length minus minus. So this is the pseudocode for deleting an element from a given index. Now one more thing we should take care that the index should not be out of the range. Like I have only 8 elements, I am giving index as 10 or 12. Beyond the length of an array, it should not go beyond the length. So that you have to take care. So that we'll be doing it when we write the program. Now let us analyze how much work is done here. What is the time complexity? See, copying the element from a given index takes 1 unit of time, and decrementing length takes 1 unit of time. And this loop, the statement that is shifting the elements, how many elements are shifted? So depends what index I have given. So minimum 0 elements are shifted. If I was deleting the last element, then nothing has to be shifted. If I am deleting the first element, that is index 0, then all have to be shifted. So minimum shifting is 0, maximum shifting is n. So minimum shifting is 0 or maximum shifting is n. So again, the minimum time is a constant and the maximum time is n. So if I write minimum time is 1 plus 1, that is 2, and the maximum time is 1 plus 1, 2, as well as n. So n plus 2. So the best time is 2, that is constant. Worst time is n, that is maximum. So best case is what? If I am deleting the last element, no shifting required. Now right now, if I delete 10 from here, if I want to delete 10 from here, then directly 10 is deleted. No elements beyond 10, so no shifting required. So the best case time is order of 1. Worst case time is order of n. So that's all about deletion. So we have finished deletion. Now next will be search. So we'll learn about search.